The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Hey, Ben.
Hey, what's going on?
We had all these extra parts laying around, and a TFT screen, a Raspberry Pi, and a camera module, and I made a point-and-shoot camera out of it.
Oh, Raspberry Pi camera. That's pretty cool. What do you want to do with it?
I'm thinking, well, I made it as kind of bulky, and maybe you could slim it down and make a nice little enclosure for it.
Oh, yeah. I think we could do that. Remove as much as possible. Like, we don't even need the HDMI, really. Yeah, I think I can help you with that.
Cool.
So that's what we're going to do in today's episode. We're going to slim down this Raspberry Pi camera. It's a 5-step program thanks to Jenny Craig, and soon it'll be ready for bikini season. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
Okay, Ben, let me show you the parts that I use for this.
Okay.
I have a battery in here already, but I'm thinking this battery would probably be better.
Yeah, it's smaller.
I have the Pi TFT camera from Adafruit.
Oh, nice.
The camera module, the Raspberry Pi Model B, SD card. This is a breakout, we don't need any of that. But the battery charger, and that's pretty much all the parts that would be necessary.
And there's a main power switch someplace?
Yeah, I have it hooked on this dip switch here, but...
So it'll auto boot into the camera? All right, cool. And then is there a safe way to turn off the Raspberry Pi?
I have this soft button here.
Oh, okay, that's built into the Adafruit module. All right, neat. Is there a way to add an external shutter button instead of tapping the screen?
Yeah, we could either break out from the GPIO or add another button in these. The GPIO is also broken out here.
Oh, okay, I guess we have options then. Well, I think the first step will be to shrink everything down to make sure it still works and then design a case around it. Felix has the camera kernel working, so it's up to me to build it mechanically to make it as small as possible. I'm going to remove pretty much everything off the Raspberry Pi. I might leave the HDMI in place, but maybe not. One thing about a lot of these modern electronics is that they're all RoHS, restriction on hazardous substances, in this case lead. And the reason why you have to be cognizant of that is because when there's internal ground planes, most of these boards are 4-layer, or at least 4-layer. Internal ground planes means it'll sink a lot of heat and you can't see it, so it's hard to remove components that are through-hole when it's lead-free, but not impossible. So I will show you some tips and tricks as I depopulate this Raspberry Pi. I wish they just had a Raspberry Pi that had nothing populated, and then you could add what you wanted. I'm going to start with this composite video connector. I've got my desoldering iron on, but I'm going to show you some of this without it. I'm going to continually heat it with my iron. I'm using my Weller, which has variable speed. I've got it about, actually I'm going to crank it up a little bit more, go up to about 700 Fahrenheit. Lead-free solder has no lead, which is a soft metal, which means it needs more heat in order to make it flow. I'm going to do my wedge method. Stick my screwdriver under there, continually heat these. Come on. Yeah. 1, 2, 3, 1, 2, 3, 1, 2, 3. You'll see it start to move. Let's do this a few steps at a time. And you can use this method to remove things if you don't have a desoldering iron, although you should use a desoldering iron. Guess if I was using the new Raspberry Pi, it wouldn't have this old port on it, but whatever. That squeaking is a sound of victory. Oh, that's quite warm. There we go. And after you've removed a part like that, go ahead and re-tin it a little bit, just to make sure that there's no solder flowing where you don't want it to go. Okay, now I'm going to do the headphone jack next. It feels like we've done this before on our project, have we? Got deja vu. All right, see how there's a gap around the pin that I removed? That means we're good to go. When you don't see a gap, that's usually when you know you've got to desolder it more. So I'm gonna leave the iron on there for a few seconds before I release it. Yeah. These look like they're coming pretty decent. So when I put the iron on, I put it on, then I move it to the left to move the pin. The reason I do that is because then I know I actually am contacting the pin as much as possible with the hot iron. So I'm actually heating up the pin, not just the solder around it. This one feels okay. Yeah, that's pretty easy. All right. This header here is the one we're going to be using for the camera. So this one we don't need, although I'm probably going to just remove them both. Because look how far up they stick. Not efficient at all. Let's try the Ethernet. Okay. The Ethernet, these are going to be data lines, although one is probably ground. And then these are mounting points through the PCB. So that's where you're going to run into the problem with internal ground plane. We can try desoldering them though. Of course, the width of this pin might exceed the diameter of my desoldering iron tip. So what we might do is just do the rocker method again. Again, I'm going to flow these with some solder just to prime them. Let's see if this fits. That actually did a pretty good job. Let it heat up, let it heat up. Remember, if there's ground planes that you can't see, they're going to be copper. They're going to sink a lot of heat. So they're going to be sinking heat away from the pin that you want to desolder, which is why you want to make sure you leave it on there for a decent amount of time to make sure you heat up enough stuff that you also are heating up your target. It's actually coming pretty good. Most of the solder ends up on my shoe. Which is why I never wear shorts, because there's always solder splattering around. Plus I have white, pasty Irish legs. Oh yeah, that was easy. All right, let's do the Ethernet next. These have been coming off really easy. Maybe too easy. Now it's time for a tech timeout.
Hello, Felix here. As a local resident Linux enthusiast, I'm here to explain to you how we set up the Raspberry Pi to behave as a point-and-shoot still camera. First thing we had to do was download the operating system and set up the SD card. After that, we did the initial setup of Raspberry config, update and upgrade. After that, we went ahead and set up the TFT screen, the GPIO, and the camera module. After that, we got the still camera software working from Adafruit. And once all that was completed, we wanted to make it so that it could automatically boot into a still camera mode. So we did a detailed screencast of the entire setup process of the Raspberry Pi.
The header desoldered well, but I am not sure if I can get it out in one piece. I'm gonna try rocking it back and forth a little bit. Part of the reason is I'd like to keep this header because these are actually worth money. But at a certain point I'll give up and do a different method. Oh, wait. This reminds me exactly of when I got my wisdom teeth removed. It's the most expensive 20 minutes of my life. Ah, not too bad. One straggler. Cool. I'll keep this. Male double roll. There you go. So far, so good. Look at how much thinner it's getting. Okay, so I've bent the HDMI port back, and the first two pins are free, these two. Now I'm going to free the rear pins as much as I can. I don't want to damage the surface mount. Oh, well, don't want to damage it too much, I guess I should say. So once I get the big mechanical tabs free, then I can just break all the connections from the back of it since we don't need HDMI. Just gonna use an X-Acto knife and cut these. Hopefully that's not a terrible decision. It could be worse. So for this piece, I want to desolder these pins, but it'll actually be easier with this plastic shroud gone. So I'm gonna cram my screwdriver in there and actually pull the plastic up off of the pins. See that? What I can do now is I can just heat these up and remove them. So they're a lot easier to remove because they're not, you know, trapped in the plastic. The Raspberry Pi has been broken down to its bare essentials. I could probably remove this, but I don't really need to. I can save a little bit of height, but it's not necessary. So now I'm thinking about how to attach it to the LCD shield. The shield has all the GPIO lined up right here, so I could connect them right on top of each other using some headers. Well, it's actually probably the best way to go. So it'll keep everything pretty thin. Actually, I think I will remove this USB plug. It's actually not necessary. You can wire 5 volts directly to this GPIO header. Might as well try to make this as thin as possible. Now this is the header that will attach to the camera. So what I'll probably do is remove the ribbon cable from the camera as well and wire that all manually. Now I'm going to remove the zero insertion force header from the camera so I can attach the camera right here. Yeah, it'll be super compact. I've manually wired a ribbon cable going from the Raspberry Pi to the Raspberry Pi camera. I'm going to put some plastic down to insulate it, and then I can fold the camera over and glue it in place. I ripped apart the USB Wi-Fi dongle, and this is what is left. It's pretty cool how they compact that all in there. And I'm gonna build this right onto the board, I think. Yeah, so we don't even need a USB slot. I'm gonna add a power connector so Felix can test this out. We'll make sure that it still works before we go any further with it. Here are the broken down components. We have the screen and the Raspberry Pi, which has been flattened quite a bit. I 3D printed these spacers to make sure the pieces fit together at an equal distance and nothing touches. And there's actually a little bit of gap on top of that. To connect the sides together, I'm going to use the GPIO connection since we need those anyway. Still no leads in the case of the Hydebox Snoogler. It's called snoogling, Doug, an act that originates from America. We believe it involves guns. Wait a minute. Why did I remove this if I'm just putting it back on? Oh well. The rewired camera still works. That's good. So next I'm going to attach a battery for the power supply. Right now I have it running off my bench power supply. This is the lost secret of Atlantis, Junior. Atlantis doesn't exist. Yes, it does. You have to believe. I am going to modify this charge circuit so we can build it right into the camera along with the battery. This charge circuit will take the 3.7 volts of the battery and boost it to 5 to power the Pi, and then we can also hook a USB port into it in order to charge it. One-stop shopping. I need to think about the best way to mount this. Probably put this like right here and then attach the battery there. The battery actually adds quite a bit of bulk. So you'll see I can make it either thinner by putting the battery side by side, or I can make it smaller on the XY by putting the battery like this. So I'm going to play around with the dimensions and see what the best fit is. Alex Odell sent us a box of connectors. Maybe we can use them in this project. Here's a micro SD slot. It's a nice click in, click out one as well. So we could remove this and just have this. I mean, the new Raspberry Pi has a micro SD on it, but this one doesn't. See? We could save a lot of space that way. Well, there's a couple different types of them too. I manually wired this micro SD card. I'm going to place it here and then manually wire its connections to where the SD card was. So I wrote down the connections of the micro SD card and I'm going to match them to the pinout of the full-size SD card. These two pins right here were basically a card insertion check. You can see it here. When I put the card in, it closes that, so it knows that there's a card in place. I'm going to wire that as well. This micro SD card has the same connection over here on the right. There aren't two pins for it, but one of them is ground, so it'll work as long as I also ground the chassis of this SD card connector. So time to start another tedious wiring job. I've rewired the old SD card connector to the micro SD pinout. Let's see if it works. SD card is in place. There it is. My manual wiring of the micro SD card worked. This outer wire here is the card insert detect. Basically, when you insert the card, it closes the switch on those last two contacts. One of them is ground, and so this is grounded there. So this wire was necessary because the Raspberry Pi probably does look for that. You know, make sure the card's actually inserted before it even tries to boot to it. Oh, and the camera's up and running. Sweet. Now we just have to install the battery and the charger. I had this PlayStation 3 controller battery laying around for years. I'm finally going to use it. It's fairly small, but it does boot. I think we'll put that right there, and we'll put the charger module here. Yeah, that way you can charge it through the side with the USB plug. I think this is our best bet, so I'm going to work these into the motherboard. Here are the components all working together. The enable line is connected to the switch, and the other side of the switch is connected to ground, so when you turn on the switch, enable is pulled low, which turns off the 5-volt output. So the opposite position of the switch, the system, will be on, selfie. All right. Then we have our PlayStation 3 battery here, SD card, PlayStation battery power going to the power adapter, USB charge jack, our Wi-Fi module, the camera, shutter switch, and then this side we're going to have a button for shutting down the system, and the shutter switch will also act as the, well, right now you tap the switch to take a photo, but you can also push this. Now that everything is in one convenient unit, it's time to make an enclosure for it. We've printed the two halves of the case, the front and the back. The back has a big hole in it, of course, for the display. Gonna put a little spacer here to hold the battery in the right spot. All right. I made the case just barely larger than the parts inside of it, so as long as we put everything into the case, it should be held tight. So our shutter button is here. Still get at the SD card right there. Power switches on the bottom, USB chargers on the side. I measured the exact size of the screen, and then I made a 0.02 space around it just to make sure that it had enough slop. And then we have our safe power off button here, so you can properly shut down Linux. There was some lifting on the print because my heated bed connector came loose, which I have to fix, but yeah, it works. Actually, kind of gives it a built-in curve. The Raspberry Pi camera is now put together, so to test it, Allison and I are going to take some selfies. I'm going to take a serious selfie here. Hopefully no one photobombs it. You should take a selfie now. Take another selfie.
Do your male model pose.
Male model pose? Okay. This is what I have to deal with every day. Well, that was fun, hand wiring a Raspberry Pi point and shoot camera to try to make it as small as possible. We did a pretty good job. Well, that's all the time we have for today. In our next episode, we're going to finally revisit the can crusher, using your suggestions to build a household can crusher that can help you recycle. We'll see you then. pitch it as Harry Potter with machine guns. And they're like immortals and they're trying to kill each other or something. It's all Alanis Morissette's fault. Hey, remember in Dungeons and Dragons when Blue Lips was like, I made a cut. Remember that? That was his big line. Yeah, but so I guess in the second one, to make a sequel, they had to like change the whole plot, so it's like they're aliens or something. It sounds awful. Oh, you mean like shrink it down and then give it an enclosure?
Can we try that again?
Yeah.
Hey, Ben, what are you doing over there?
Nothing important.
Whatever. Hey, I made a camera. Check it out.
Probably too much laughing. Now you know what I have to do with. Fan, please. Switch tomorrow.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.